Good evening. My name is Caryn Turrel. I am a curriculum and training associate with the National Energy Education Development Project based out of Manassas, Virginia in the United States. About 2 months ago, I think it was, the Korean Energy Information Agency contacted Rebecca Lamb in our office to start a partnership where we can start working on some energy education materials for the Republic of Korea. And this webinar is a first step in that partnership. We anticipate that there will be more educational materials and more energy training coming in the future, and we're really looking forward to it. Today I'm going to talk to you a little bit about carbon neutrality and net zero and how they fit into climate change and how those terms are applied. So just a little bit of background. When we talk about carbon, it's usually because of energy use. And so I wanted to start by painting a picture of how energy is being used in the Republic of Korea in terms of the energy sources. So there are three major sources shown here. This is 2019 data, so it's a little older, but it's the most recent that we had available to us. Petroleum is the greatest energy source, and it's about 42% of all energy, including transportation fuels and heating and all of that sort of thing, followed by coal and natural gas. These three are fossil fuels. So using these three energy sources means burning them, which generates carbon dioxide, which is a greenhouse gas, and that's going to be the thing that we focus on. The last 13% is nuclear energy and all renewables, so wind or solar or geothermal and what have you. That's all in that 13% purple wedge there. When we look at greenhouse gas emissions, there are three major gases that we need to look at. The first one is methane, and you can see in the chart on the left, that purple wedge, only about 16% of emissions are methane. And methane is a very potent greenhouse gas. It is released when vegetative matter or organic matter decays without oxygen present, and it can also be released when there are cracks in the earth or when we are producing petroleum. So there are a lot of sources of methane. Emissions in this case means man-made emissions or things that human activity cause that gas to be released. The next wedge to look at is that green wedge, that carbon dioxide from forestry and land use. That's not as much of a concern or a focus when we talk about climate change, but it is contributing to the amount of greenhouse gases in the atmosphere. The very large piece of that pie chart, that carbon dioxide from fossil fuel use, that's 65%, that is the piece that we need to get down in order to get climate change under control. And then there are two other gases that are counted, but really are not a big concern. The first being nitrous oxide and the second being fluorinated gases or gases that have fluorine in them. They are effective greenhouse gases, but the focus right now is on carbon dioxide primarily and then on methane secondarily. If you look at who's producing the most greenhouse gases by sector across the globe, you can see that electricity and heat production is the biggest generator of those greenhouse gases. About 25% of all greenhouse gases come from generating electricity or burning fossil fuels for heat. Industry is another 20%, and agriculture, forestry, etc. is about 24%. Transportation is a smaller amount, but in industrialized countries, it's a much larger percentage. So one of the focuses is on transportation. So what is the greenhouse effect? What are greenhouse gases and how do they work? We live in a very special planet because we have this atmosphere that acts like a blanket to help us stay warm at night. Think about the moon, and the moon does not have an atmosphere. The sun side of the moon gets very, very hot, and then the dark side of the moon is very, very cold. And we would not be able to survive if we did not have an atmosphere working as a blanket to help us stay a little bit cooler during the day and to keep us warm at night. So it's a good thing to have a little bit of a greenhouse effect. Gases in the atmosphere, like carbon dioxide and like water vapor, trap and hold heat as it radiates back from the surface of the earth. The problem becomes when you have too much of a good thing. And carbon dioxide building up traps and holds more and more heat in the atmosphere. And so that creates an increasing temperature effect. So this is data from the United States National Oceanic and Atmospheric Agency, or we just call them NOAA. You can see the graph on the left shows what atmospheric carbon dioxide levels have been since the mid-1700s. This is measured in parts per million. The pre-industrial average carbon dioxide concentration was about 280 parts per million in terms of carbon dioxide. And if you go back in data, even through thousands or hundreds of thousands of years, that's been the average. It's gone up and down a little bit, but we are now sitting at the threshold of 415 parts per million carbon dioxide. And none of the data, none of the paleontological data supports a level this high. In other words, never in Earth's history has carbon dioxide been at this level. So the industrial era, the industrial revolution, when we started using coal and then petroleum for our energy needs, brought about this increased concentration of carbon dioxide in the atmosphere. And if you look at the graph, you can see, oops, let me get the right. So it was increasing a little bit, but now the rate of increase, as seen by the steepness of this graph, shows that not only are carbon dioxide levels increasing, but they're increasing faster and faster as time goes on. So we call this the hockey stick graph because it looks a little bit like a hockey stick. And you can see that since the 20th century, the slope was high, and then since the turn to the 21st century, the slope of CO2 concentrations has really increased. Over here, we have our global temperature change since 1880. The blue line is showing the year-to-year data, and then the 5-year average is the green line, and it's a little bit more smoothed out. But you can see the trend. This line right here, this 0 line, that's normal. That's what we would expect from year to year. And so anything below that line is representing temperatures below normal, and anything above that line represents temperatures above normal. And you can see that since about 1970, temperatures have remained on a global scale above normal. That doesn't mean you won't have cold weather or abnormal or unusually cold weather in your area. This is climate. Climate is an average, or all the data put together. Weather from day to day changes, especially here in the Midwestern United States where I live. We have changing weather all the time. But on average, across the globe, temperatures have been increasing. And notice this graph stops at 1.2 degrees Celsius. Climatologists tell us we need to keep the global temperature increase below 1.5 degrees Celsius if we're going to be able to reverse the effects of climate change that we are seeing. If we get to that 1.5 degrees Celsius, it's possible that we may not be able to reverse it no matter what we do. So what are some of the indicators of climate change? So the first one we talk about, of course, is temperature. This is data aggregated by NOAA, and it's showing temperature anomaly in greater detail around the globe. And these bars, the blue bars or the red bars, are measurements made at the surface, either ocean temperatures or land temperatures. The green and yellow lines are data collected by satellite and then analyzed statistically in 2 different ways. The UAH and RSS represent 2 different methods. I am not a mathematician. I don't know what those methods are, but if you wanted to, you could visit the NOAA website or the EPA website. We got this graph from the Environmental Protection Agency. they would be able to give you more detail about how that data was analyzed. I'll give you that website at the end of the presentation. So here's another climate change indicator, and this is a rendering of data collected about Arctic sea ice. The Arctic Ocean has ice on it year-round, so that if you wanted to go to the North Pole, you could walk. Maybe. The picture on the left is from September 1979, and you can see this is at the end of summer, and there's still quite a bit of ice covering the Arctic Ocean. Then the other image on the right is from September 2003, and you can see that in just that time span, Arctic ice diminished significantly. I imagine, although I don't have the data, they're probably still processing it, that the amount of sea ice in September of 2020 or 2021 has been significantly less than even the picture on the right. Another climate change indicator are extreme weather events. Now here in the United States, we tend to measure hurricanes in the North Atlantic, but in the Pacific, you are subject to tropical storms as well. I think you call them cyclones or typhoons, well, we call them hurricanes. They're all the same kind of storm. The red line is showing the number of hurricanes that have actually reached the shore of the United States. The green line shows the actual number of hurricanes observed. And then that orange line between 1880 and 1960 is the number of hurricanes formed that was adjusted based on the inability to see them from an airplane or from a satellite. So they took that data and they said, hey, how many would we have seen if we had the ability to fly over or to have a satellite take a photograph? So when we talk about an adjusted number, that's what they're adjusting for. And you can see that in the 1950s and 60s, about 6 or 7 every year, dropped down a little bit in 1980, 1990. But since 2000, that number has increased significantly. The last time hurricane numbers were this high was in 1890. So what can we do to get climate change under control? Well, first of all, we can reduce our fossil fuel consumption. Burning fewer fossil fuels for energy releases less carbon dioxide into the atmosphere. We can shift our electricity generation over to nuclear power. Nuclear power does not have carbon dioxide emissions associated with it. There may be some carbon dioxide in the steel and concrete used to build the structures, but once that structure has been built and electricity generation has started, there is not any carbon dioxide being released. There may be some water vapor, and water vapor is a greenhouse gas. However, we don't concern ourselves with it because the atmosphere cannot absorb infinite amounts of water vapor. So if there gets to be too much water vapor in the atmosphere, you'll get clouds and then you'll get rain. Carbon dioxide doesn't do that. So nuclear power just has, some heat energy that is released and maybe increases the water vapor around the power plant, but that averages itself out by forming additional clouds or rain somewhere else. In your everyday living, bring some energy management skills into things that you do. Can you carpool? Can you combine trips? If you're running errands, can you just drive and do several things on one day and then not drive your car the next day? Can you ride your bike or walk to get someplace? Can you change the temperature on your air conditioner or on your heat so that it's running less and burning less fossil fuels? Can you use better lighting like LED lighting or more energy efficiency appliances like washing machines, refrigerators, and the like? Can we increase the fuel efficiency of our vehicles? There's a lot of talk here in the United States about electric vehicles that plug in and whether our grid can handle the additional demand of these EVs and whether we can drive our cars the way we like to drive them. Currently, a road trip in the United States is kind of a thing. People go on a road trip and they drive several hundred or even several thousand miles on a vacation. Will EVs be able to do that? That's a big conversation here. But using electric vehicles is going to decrease overall the amount of carbon dioxide released to the atmosphere. And the reason for that is because mile for mile, electricity generates less carbon dioxide than gasoline or diesel fuel. I have a panel here that says buy local. And buy local just means the more something has to be shipped and handled, the more carbon dioxide is released into the atmosphere. We enjoy eating fresh vegetables in the middle of winter because our friends in Florida and California can grow them in their warmer climate and ship them to us. But that shipping has a great carbon dioxide emission, or big carbon footprint, we would say. So I don't know the situation for you in Korea, but if you have a local grower of vegetables rather than having something brought in from a market far away, you have reduced your carbon dioxide emission. Or even better, if you have space to grow your own vegetables in your yard or in your community, and you can just walk and pick them, they're fresher, they're tastier, and it has a lower carbon footprint. The two big strategies that large entities like corporations or universities or communities will take are called carbon neutrality and net zero. And these are things, the principles of these can be applied by individual families, but usually if we're talking about somebody is going carbon neutral, it's a corporation, or it's a government, or it's a university, some large agency that's going to subscribe to one of these two strategies. So the first one is carbon neutrality. And carbon neutrality looks at what we are doing and how we can offset that elsewhere. We don't adjust what we're doing to change our own carbon dioxide emissions. We just look for places where we can reduce carbon dioxide in the atmosphere other places. One of those ways to reduce atmospheric carbon dioxide is through a process called sequestration. Sequestration is when we capture carbon dioxide at the source where it is generated and then put it under pressure and liquefy it and inject it into geological formations underground or in tanks. It can be used, so you can take that carbon dioxide and use it to pressurize oil wells that have dropped in pressure and have dropped off in production. That carbon dioxide puts pressure on the liquid in that oil well and forces that liquid up out of the well. And then the carbon dioxide stays in that formation and is sequestered away from the atmosphere. That's one thing we can do. It's not a very effective strategy to adopt, and not because it doesn't work well, but because it's extremely expensive to do, and most organizations don't have the finance available to support that. So another strategy to reduce atmospheric carbon dioxide is through a process called reforestation, where you're supporting efforts to replant trees where they have been cleared away. And this is a big problem in the Amazon jungle, where trees, and in Central America also, trees have been cleared for agricultural purposes. And so the crops that are grown there don't remove as much carbon dioxide as the trees that used to be there, or the heavy undergrowth that was under those trees. So reforestation of those areas is critical to getting the lungs of the planet breathing in the carbon dioxide and breathing out the oxygen that you and I need. The important thing to note here is when a company is declaring themselves carbon neutral, they are not adjusting their processes at all. So let's say I have a steel factory and I'm producing steel. Making steel is a high carbon dioxide producing industry. There's a lot of carbon dioxide in just extracting the iron from the iron ore. There's a lot of carbon dioxide in combining the iron with carbon to make steel. It's a big, heavy, we say steel has a big carbon footprint. If I'm not going to change the way I make my steel, but I want to go carbon neutral, I need to then find other places. And so I might invest in renewable energy. So perhaps I can fund a solar farm somewhere, which is going to shift electricity production from burning a fossil fuel over to using solar energy to generate electricity. Perhaps I can engage in some energy efficiency measures in my community. I can support some of those kinds of things where I perhaps purchase some electric buses for my community, which are going to use less or emit less carbon dioxide. Or I can do something called purchasing carbon credits. And what that is if I have a steel factory and I have the money to do so, I can then pay somebody someplace else to not produce carbon dioxide. And that's called a carbon credit. There is some controversy about the social implications of doing that, where that puts the burden of supporting climate change and mitigation of climate change. So when you talk about purchasing carbon credits, some people might think it's a really great idea, and some people might bristle at that and say it's just not an effective idea. So that's carbon neutrality. Carbon neutrality is I'm not really changing what I do, but I'm looking outside of my organization or my community to make changes other places. Net zero it takes it a step further. So carbon neutral is a good start. Carbon neutral looks at this is what my carbon footprint is. What can I do to overcome that or make up for it? Net zero is another strategy that takes and looks at what I am doing, and I'm going to reduce my carbon emissions, and I am also going to look outward at how I can improve things in my community and decrease carbon emissions there as well. So let's go back to pretending I own a steel factory. There are ways of manufacturing steel that have lower carbon footprints. So maybe that's what I would do as a steel factory owner or a steel corporation owner. I would say we are going to shift over to these other methods of producing steel that have lower carbon footprints. And so that's going to reduce our carbon emissions. Maybe we will install LED lighting and have motion and light sensors so that we don't have lights on unnecessarily. Maybe we will implement a program in our corporation of changing the temperature to be just a little bit warmer in the summer and just a little bit cooler in the winter. Those kinds of things are going to bring my corporation, my pretend corporation, bring my carbon emissions down. At the same time, I'm also going to reach out and support reduction in atmospheric carbon dioxide elsewhere. I might invest money into a sequestration project. I might invest money into a reforestation project. I might purchase some carbon credits somewhere. I might bring some energy saving technology into my community. All of these things that I do, both within my own organization and outward, should take my carbon emissions to essentially no change in atmospheric carbon dioxide. So I'm acknowledging that I produce a lot of carbon dioxide. I pledge to bring some of that down. And then I also pledge to find ways to decrease carbon dioxide in other places. So when those two things are added together, they zero each other out. And so that the carbon dioxide in the atmosphere is not going to change because of what I'm doing. And that's what net zero is. And net zero is the focus of the United Nations Race to Zero campaign. So the United Nations has identified that we are in a climate crisis and that climate change is an emergency problem that we have to address right away. And they started the Race to Zero campaign in order to first of all, to get awareness of the issue, but also to get actual groups on board. They call these entities actors, different kinds of actors, and get them into pledging to be net zero by 2050. So to date, there are 1,049 cities, 67 regions, 5,235 businesses, 441 investors, and 1,039 higher education institutions, universities, and colleges that have pledged to be part of the Race to Zero campaign. We see time and time again that college students in higher education take charge and take the lead of these kinds of things, and as an educator, it makes me really proud to see that it's the frontier is being led by higher education institutions. So keep it up. Okay, I'm going to go through 3 different examples of what universities are doing to address their carbon footprints, their carbon emissions. And these are 3 universities are part of the Race to Zero campaign. And you're going to see they each have very different approaches, but it gives you an idea of what universities can do. The first one is Chiba University of Commerce in Japan. It's right in the central part of Japan near Tokyo. They are the first 100% renewable energy in Japan. There are 780 universities, according to their website, and this is the first one to achieve 100% renewable energy. They established something called the Renewable Energy University League of Japan last year, and this is an organization that is friendly competition to get other universities in adding renewable energy to their campuses and shifting from using natural gas or petroleum products and using renewable energy sources like solar or geothermal or wind energy. They installed a large ground-mounted solar array, about 2.5 megawatts, just outside of their campus. And they have been installing rooftop solar on most of their buildings. So the total solar that they've installed is about 6.5 megawatts. It's not a ton, but for the university and the other measures they're taking, they can use this solar energy then to meet their electricity needs. They've had voluntary activities that involve faculty, staff, and students. The key word here is voluntary. None of this was forced on anybody. What they did as a university is they presented the problem and presented the challenge, and that got people on board. So they formed something called a student patrol. It's just a group of students that go through and check to make sure lights are off in buildings, thermostats aren't set crazy, if the heat is on, the door isn't left open, those kinds of things. They're just going and checking the buildings and being the eyes of the facility staff so that they can keep things under control and keep things operating efficiently. They had an awareness campaign. I imagine this was in the summer. They wouldn't have done this in the wintertime, where they had water sprinklers outside to cool people off. And it was designed to allow them to put that air conditioning temperature at a little bit warmer level in their buildings so that people get a little bit wet and they're a little bit cooled off when they come inside. They don't need it quite as cold indoors. It was mostly just an awareness campaign of, hey, there are some things that we can do to help change what we do. And then there was a symposium on campus of community leaders and university leaders and faculty and students to come up with ideas and strategies for addressing being race to zero or being net zero by 2050. So they took a 3-tier approach. The first one being hardware. So the different things that they installed, their heating and cooling systems, their lighting systems, looking at windows and doors and construction, actual physical installation of controls and computer systems to keep lights off when they shouldn't be on, to keep temperatures at a reasonable level, and then the software needed to run those systems. But they addressed something else called hardware. And this isn't anything we really have seen referenced anywhere else, but I like the term hardware. And it's getting people in the mindset, not just the knowledge, but the value system and the mindset to achieve net zero, to get people to understand that having that thermostat set just a little bit warmer in the summertime might be slightly uncomfortable, but it's going to be better for the planet in the long run. Or maybe I drink a glass of ice water, which I have right here, instead of turning my temperature down to a lot cooler. Okay, so that's what that hardware is. I like that. I think I might adopt that term. It's a mindset. It's a value system. It's not forcing anybody to do anything, but getting them and educating people to understand where we're going. So I understand these slides will be uploaded to a website to make it possible for you to learn more information. So this little icon here takes you to the YouTube video that the university released about their program. It's a longish video, so you'll want to spend the time watching it, but there's a lot more information about what they have done in their program in Japan. Come on, machine. There it goes. The next one is University of Glasgow in Scotland. So they have a program called Glasgow Green. They want to be carbon neutral by 2030. They're still part of the Race to Net Zero campaign, which is net zero by 2050. So carbon neutral by 2030, net zero by 2050. That gives them 20 years to bring their own carbon emissions down to equal the offset, so it really is a net zero. So it's important to make that distinction. They're working and they're going to get to carbon zero by 2030, but they're not going to be at net zero at 2030. They'll be at net zero by 2050. So they have 5 categories of actions they created. The first one, engaging and empowering the community. So University of Glasgow realizes that they don't live in a vacuum, that they have a surrounding community, and it's their campus community as well as the community around the campus. They're going to promote efficiency. They have governance and policy actions they're going to take. Continuous improvement initiatives. It's not going to be, hey, we did this and now we're done. I mean, hey, we did this, we got this far, now what else can we do? And keep looking for ways to improve. And then building resilience through partnerships. Since they enacted this policy or this campaign for between the 2015 and 16 school year and the 2018-19 school year, carbon footprint dropped 13.3%. So that's a 3-year period and a 13% reduction over those 3 years. That's pretty significant. So there are things that they're looking at that they're going to be doing. They're going to make improvements to their heating, ventilation, and air conditioning systems. There are much more efficient materials. If you cannot move away from natural gas as your heat source, it's a really good heat source. If you cannot move away from natural gas as your heat source, you can invest in more efficient equipment that will use that natural gas in a smart way and bring your natural gas use down. Or maybe you can install a air source, water source, or even ground source heating system that's a heat pump. They're going to use water source heat pumps in a couple of their buildings starting in 2025 and 2030. There's more details about which buildings and what effect that's going to be, but it's going to remove some natural gas from their portfolio, from their carbon footprint, and it's going to put in a non-carbon emitter as a heat source. Water source heat pumps use a groundwater source as a constant temperature source of heat. And so in the wintertime, they use a reverse refrigeration process, or the reverse of refrigeration, and use the water as a constant temperature location to direct heat into the building. And then in the summer, it's the opposite. It's using the groundwater source as a constant source of cooling. And then they're going to add solar panels where suitable. Now, if you're familiar with Glasgow, it's far north and they can have some pretty dreary days. And so solar may not be as effective as a place like Japan or in some parts of Korea where you get more sunlight. Glasgow can be pretty cloudy. So they're going to use solar panels where suitable, where applicable, but that's not the focus of their plan. Their plan is mostly going to be these heat pumps, these air source and water source heat pumps, to take some of their oil and gas offline and bring in non-carbon sources. The third one I want to tell you about is the University of Toronto in Ontario, Canada, in North America. So this is an urban campus. The campus of St. James is right in downtown Toronto. Toronto is a large city, similar to London or Paris or Seoul or Tokyo or New York. And this is a university campus. It's right in downtown. So the first thing that they have done is they've taken some of their investments away from fossil fuel companies. So the investiture of the university, where they've invested their assets and invested some of their money to earn dividends for the university, they took those investments away from fossil fuel companies, so away from natural gas producers, away from oil companies, and put them in more green industries. The downtown campus has a goal of not just being net zero, but being what we call climate positive by 2050. Now, what that means is they're going to go further than zero for their carbon emissions. They're going to go further than, like, if their carbon emissions are at 50,000 pounds per year and they're offsetting more than 50,000 pounds per year, that they're not just net zero, they're net negative in terms of carbon dioxide production. So they're going to have an absolute 80% reduction in carbon emissions for their campus. That is a lot of a reduction. Excuse me, 80%, that's almost, 4/5. That's a big reduction in carbon emissions. Then they're looking outside of their campus, but still in their local area, still in Toronto or in Ontario, and investing in local clean energy production that results in more than 20% of their current carbon emissions being reduced. So they're going to take away 80% of their own, and then they're going to invest and bring down that last 20% plus off campus, but still close. So that results in more than 100% reduction of their carbon emissions by 2050. That's what it means to be climate positive. You will see a lot of different terms. You'll see carbon neutral, carbon positive, climate positive, net zero. And it's just this very unpacking what that language means can be confusing. Most of the time, the scientific community and government entities are using carbon neutral or net zero. This is the climate positive is being used to indicate we're not just going to stop at our 100%, we're going to go further. They're going to have strict carbon budgets for all new construction. When you're building a new building, every material, every process has its own carbon footprint. There are ways of certifying buildings as being green buildings based on the carbon footprint of those materials. Concrete has a very, very large carbon footprint. Just the way that the Portland cement is manufactured and then transporting the concrete, that has a big carbon footprint. So using other materials that have lower carbon footprints, also having construction be a very energy efficient building, so it's well insulated, it has good airflow, it has efficient heating and cooling and lighting, so it's using less energy per square foot. All of those things are going to go into all of their new construction on campus. They're going to take a look at their steam heat in their older buildings. So I'm not sure how it is in Korea, but here in North America, a lot of older buildings use boilers that boil water to steam and then circulate the steam through radiators. It's not a real efficient method. Sometimes you get pipes that are heating up and cooling down, and so there's a lot of banging and clunking going on in those pipes. You can have steam leaks, and so that leads to an inefficient system. And just the amount of energy it takes to boil water into steam is a lot of energy. So they're going to look at more efficient methods. One good way of doing that would be to stop using steam and just circulate hot water in their boiler system, change their systems to just being boiler systems. Large cities will have central steam plants that send steam out into the buildings, and you just tap into that central steam source. That's also a fairly inefficient way of heating. It'd be better to, if you're in an apartment in a big city that has that steam, it'd be better to shut the steam off and get what's called a mini split, which is just a unit that installs in an outside wall, so it's got part of it outdoors and part of it indoors. And then you control the temperature of your space with that machine through winter and summer. It does heating and it does cooling, and it's much more efficient. So they're going to take out all of their steam heating to make it more efficient, and then they're going to install or add ground source heat pumps. In the United States, we call that geothermal heating and cooling, but it's basically using the ground as a sink for heat as opposed to the air or ground-based water. And those are very, very efficient. Those have very low carbon footprint. The only carbon footprint is the electricity to run the compressor and fan and pump in those situations. And then, of course, the manufacturing of it. But the actual source of the heating and cooling is a zero carbon emitter. So those are 3 examples of what they're doing in universities. And you can see that each of those situations really needed the cooperation of the people at the top, right? So you're a college student. You want to know what you can do to implement change on your college university or in your college community. So the first thing is to talk to the leaders of your university, whether it's your university president or starting with the dean of students or whoever you feel comfortable talking to who is high enough up and has enough authority to kind of get the ball rolling. So they want to take a look at university investments. Is your university investing in things that are climate friendly or not? There's some good investments that will have high returns of money, but they're not necessarily climate friendly investments. So that's one thing to take a look at. Can you as a university commit to Race to Zero? Contact the United Nations, see what is involved in getting into that campaign. Is that something you can then as a university join in and take part of? Can you train university facility staff in their good energy management practice? This is really important. If the leaders of an organization have a goal, if the students and faculty have a goal to reduce carbon emissions, but you don't talk to the people in charge of maintaining and running the buildings, you're going to be swimming upstream. So what you want to do is you want to make sure you get all aspects of your campus community on board. And sometimes that means facility staff need to understand basic energy management practices, how you can adjust controls so that lights aren't left on all night, or how you can adjust temperatures to only really condition a space heavily when it's occupied. And then, in the wintertime, maybe it drops down to 55 degrees Fahrenheit. What would that be in Celsius? Like 15 degrees Celsius during, in the wintertime. Or maybe you allow it to heat up in the summertime. And then when that room is going to be occupied just a little bit before class starts, you click on the heat or you click on the air conditioning and change that temperature so that it's only being conditioned when there's people in there. Those kinds of things, that kind of training for your facility staff is really important. It's that you're not going to be able to get anywhere if you don't have those folks on board. Then work with the different stakeholders around campus to set aggressive goals. So looking at new construction, can we have all of our new construction be carbon neutral? Can we use low carbon footprint materials? Can we have high efficiency buildings? Can we bring our energy use per square meter down to a reasonable level? Can we go into older buildings on campus and retrofit with better windows, better heating and cooling systems, more efficient lighting, some controls so we can remotely turn things on and off when nobody's in the building? Look at what your fellow students are doing. Come up with some solutions. So the solutions are a great place for research projects for graduate students. If you have engineering majors on your campus, or if you have environmental science people on campus, coming up with research projects that are focused on what's happening on your university campus, you can take that energy and that education and reflect it back onto your own university to improve its carbon footprint. What kinds of community or campus service projects can you do? So you have a lot of student organizations on campus. You may have fraternal or sorority organizations. You may have community service organizations, honor societies, professional societies, student governments. I could go on and on, but you know the kinds of things you have on campus. those kinds of service projects that you're always looking for can then be reflective back onto your university community to say, start a recycling campaign or install fountains that are water bottle fill so that you stop using single-use water bottles. Or there's all kinds of things you can do. Okay, a student patrol, a little friendly competition among the different dormitories about who's using less energy, and so on and so forth. You can be creative and come up with great things to do on your campus that are all going to lead to your university reducing its carbon footprint. So you want to make sure, though, that you're promoting your idea in a fun way and maybe a little bit competitive. Nobody likes to be forced to do something. The best way to get people on board with your campaign is to convince them that it was their idea to begin with, right? So if you want, I remember this when I was a kid, and my kids did it to me. Try to set things out to get me to have the idea to do the thing that they want to do. My younger daughter especially was really, really good at that. Hey, Mom, you know this? And she'd lay out her argument and then say, oh, it would be a good idea to do that. And that's what she wanted me to say. So this is what you want to do to the people on your university, right? You want to have them think that they're coming up with the idea. Lay everything out. And hey, don't you think it's a good idea that we do this? Bring them in that way. So you can have challenges, right? You can have challenges that last a week or a month or a semester or even the whole year. And you can have what I call a thermometer. It's not a real thermometer. We use these all the time in the United States. I don't know if you do, where you construct what looks like a thermometer and you have your goal at the top. And then as you're moving along, you're filling the thermometer in to show how close you are to your goal. It's not a real thermometer. I don't know why we call it that. I don't even know why we shape it like a thermometer, but that's what we do. And it's a good thing, to shade it in. Or you could, have everybody buy a little black circle when you get to a certain goal or you get a certain amount of reduction. You put a black circle on the chart and show more carbon that you've removed from the atmosphere. I don't know. You can come up with all kinds of things. There might be a really cool symbol in your region or your area that would go over really well. Have a student group who could do mini audits of buildings. So a mini audit isn't small in its scope. It isn't small. It's just not as comprehensive as a full professional audit. And by that, I mean you can use a light meter or a thermometer to check light levels and temperatures in rooms to make sure they're not overlit, to make sure they're not overheated or overcooled. Make sure that temperature is appropriate. Make sure the light level is appropriate. I was doing a mini student audit with some high school students on a college university in Philadelphia, Pennsylvania. And we went into an old building. It was built, I believe, in the 1940s or maybe 1950s. And then they had gone back and they had retrofit the lighting with all LED lighting, which is great. LED is the most efficient lighting type there is. Well, what they did, it used to have old style fluorescents. And so where every fluorescent tube was in a fixture, they put in a strip of LED lights. So if the fixture held 3 fluorescent tubes, they put in 3 rows of LED lights. So the whole ceiling was covered with all these strips of LED lights. I can tell you this right now, if they wanted to do surgery in that room, they totally could have. The lighting was 5 times higher than necessary. It was so bright, it almost hurt. We turned the lights on and I went, whoa, it was just so bright. And it was just a math classroom or just a regular classroom. So we immediately just turned those lights off because it was painfully bright. So that would be an example of an efficiency measure kind of gone wrong. They took it a little too far. Whoever was doing that didn't stop to think about how much light each of those strips of LEDs was going to produce. So you have to have your facility people understand what it is you're trying to do. But then if you have students doing mini audits and checking those light levels, if it's overlit, go back to the facility staff and say, we need to take out of each 3-row fixture, take out 2 strips of LEDs so there's only 1 left, and that will be the right amount of light for this room. And you're saving 2/3 of the energy that was being used to light that room. And over time, that adds up. That's just one classroom. We did not go into every classroom in that building, but I imagine every other classroom was made the same way. And so if you start thinking about the numbers throughout one building and then one building to another on campus and over the whole campus, those numbers start to add up and you start to realize there's a lot of energy that's being wasted unnecessarily. Students can take a look at windows and doors to find air gaps. Anytime you have a gap and a break in a seal, you have what's called air infiltration. And so in the wintertime, cold air is coming in, and the summertime, your cold air that you want to keep is going out. And it can add up to basically leaving a window open, wide open. So looking at replacing and upgrading weather stripping or making sure that windows are repaired so they close properly. When my younger daughter was a fourth grader, I did an energy unit with her fourth grade class. And the kids all knew that there was a back door that didn't close well. So they had a double vestibule. So they had an inner set of doors and a little space and an outer set of doors. And there was always snow in the wintertime in that little space. And the teachers all thought it was just the kids tracking snow in when they came in from outdoors. The kids knew that the door didn't close all the way and there was a gap about this big at the bottom that snow could blow in. There was always snow in there. And so we were doing our little student energy audit, going through and looking at our lights turned off in empty rooms, what's the temperature. And I said, now let's take a look at windows and doors. And we're like, oh, we know a door that doesn't close. They knew it didn't close. They weren't communicating that to the adults in the school. The adults in the school thought the snow was from the kids coming in from outside. So we identified that to the custodian of the building, and he was able to adjust the door close so it closed right away, and we stopped having that warm air escaping through that gap at the bottom of the door. Those little things add up to big savings. So the last thing that a student group can check for are things that are left on or running inappropriately. Computer monitors are a big part of this. If you have a desktop computer with a monitor and you're done with it for the day, but your information technology department says, I'd like you to leave the computer running so we can run updates and system checks, that's fine, but you can still just physically turn that monitor off. The monitor does not need to be left on so that the computer can run. And then the IT people can still do what they need to do with the system on your desktop computer, but you're not using electricity to power that monitor. There are lots and lots and lots of little things like that that add up to big savings. That's one of the things that I do with my job, is show students these little things that they can teach the adults in their building about. And these are the kinds of things that we hope to partner with all of you folks to help you understand. We started here with the big things, talking to your university leaders to do the big things and set the big goals. And we went down to what individuals can do on a smaller scale. But if you think about all the rooms on your campus, you think about all the places that energy is being used, little changes in each of those will add up to big differences. So here is your long view or your future view perspective about energy. Your lifestyle is one good way to reduce your carbon emission, your carbon footprint. Think about things that you can do differently that will reduce your emissions, right? But your career, what you do in your future, can have an even bigger impact. You can focus on a carbon neutral or net zero accomplishment or industry or organization, and then you can be not just in your own lifestyle and your own living, but you can then be reducing carbon for other people or showing other people ways to reduce their carbon footprints. So I have just a super short list of careers here that we need right now. There are shortages of all of these things here in North America. I imagine the same is true for you folks in Korea. Solar installers tops the list. There is a solar boom here in North America. We're installing lots and lots and lots of solar panels on houses and on businesses and for utilities, and having qualified trained electricians to understand those systems and the components and how to properly install them and connect them is really important. I'm a handy person. I know how to do some fixes around my house. I don't know how to install a solar system, even though I want one. So I would need to hire somebody who knows how to do that. Another one is wind turbine technicians, people that can work on these large utility scale wind turbines, especially now as we turn our attention more offshore. In Europe, the focus has been offshore and their technicians are offshore trained. Here in North America, we're starting to turn our attention to places offshore where we can have even bigger turbines and have a bigger return on that turbine investment. So we need people who can pilot a boat, who can pilot the right size boat. We need people who can work on these even larger machines and who aren't afraid to be 600 feet off the ground. That's not me. I would not be able to do that. We need energy auditors and managers. So energy auditors go around and check things. Energy managers are in charge of the energy use in a facility or within an entity like a university or a hospital or that sort of thing. Just kind of making sure that energy is being used appropriately as new projects come up or new equipment purchases come up, that we're making good decisions in terms of energy. There is a type of builder, if you're into construction or building buildings, building homes, to be what's called a green builder. And that just means that you're familiar with things like ground source heat pump systems or high efficiency insulation, high efficiency windows, low carbon footprint building materials. That's what a green builder focuses on and is familiar with. The old way of doing things is not necessarily the best way of doing things. Sometimes there are improvements to make. Materials scientists and engineers. So materials scientists look at different kinds of materials, different metals, different alloys of metals, different polymers, different composites of materials, and what their properties are. What is the strength? What is the temperature tolerance? All kinds of things. And then engineers, materials engineers, are looking at a problem and finding a new material to solve that problem. So for example, if we don't want to use high carbon footprint steel or high carbon footprint concrete, the engineer would look at that situation where we want to replace that material with something that has a lower carbon footprint, excuse me, and be able to replace it with a new material. And then we need people, these 5 things that I just talked about, they're all kind of STEMmy, kind of science, techie, math, right? Hands-on builder. We need the people who can communicate. We need the people who are marketing people and advertising and creative people and who are people who like to work with people to get everybody on board with reducing carbon emissions. That's an extremely important thing that we don't really talk about as much as we could, because without communication, all these great ideas and all these great programs that the auditors and the managers and the technicians and the scientists and engineers want to implement get nowhere beyond their own doors. So we need those of you who, math is not your thing, and that's okay. And science is not your thing, and that's okay. I won't take it personally. We need all of these other people who communicate well and who are creative, who can then go out and educate the public about these programs and get everybody on board. That's the future right there. So that's an extremely important part of this whole thing. All right, so that is the end of the slideshow I have, but I understand there are some questions. So I'm going to take those questions. The first one is, the European Union has now decided to include nuclear and gas in their EU taxonomy. I've always wondered whether nuclear power could be an environmentally friendly energy source. Curious about your perspective. So nuclear power kind of gets a bad rap. That's a phrase we use here where kind of it gets disrespected. Nuclear power has the capacity to be a very high level electricity provider, by which I mean can produce a lot of electricity and give a lot of homes a lot of power for a long time. One little uranium pellet, which is about the size of the end of my pencil right here, this little metal part in the eraser, One pellet that big is the same as 1 ton of coal in terms of its energy. So the energy density is very, very high. A lot of energy packed into a little space. One nuclear power plant then can generate electricity. One nuclear reactor is usually on the order of 2 or 3 gigawatts, or a billion watts of power, whereas a coal or a natural gas power plant will be rated in the millions of watts, megawatts. So gigawatts versus megawatts. And you can see where nuclear power becomes a really powerful, effective part of our our electricity generating portfolio. So the issue with nuclear power is that the plants are very, very expensive to build. There's a lot of shielding and redundancy of systems for safety purposes, and a lot of material has to go into building those power plants so that they're handled well, that the public around those power plants is protected should there be something that goes wrong. And you have to have a place to store the spent nuclear fuel. Those are the big drawbacks to nuclear power. But it is definitely a zero, once it's going, it's a zero carbon emitter, right? So if you're looking at where your electrons and your electricity are coming from, nuclear is going to carry no carbon dioxide with it. Once the building is built, that doesn't include the steel and the concrete and all the stuff that goes into building it, which is a big facility and it's expensive. We're talking about after that. So the other thing that was addressed was natural gas, and natural gas is a big deal here in the United States. We had a lot of coal plants, and as those coal plants have gotten older, and we have to scrub the emissions for sulfur and nitrogen to prevent air pollution and acid rain. As those coal plants have gotten older and more expensive to operate, power producers here in the United States have shifted those over to natural gas. Natural gas is a much faster fuel to bring on board. You can have electricity being generated within 5 minutes of it being needed. So, if you have a natural gas burner at home, you just turn a button and it sparks and you've got a flame, right? You just scale that up a few million times and you've got a power plant. Kind of the same idea. So nuclear power I wouldn't say nuclear power is totally environmentally friendly because of the radiation aspect, because of the nuclear waste. But I do think that nuclear can help us bridge from fossil fuel use, even natural gas, which is a lower carbon emitter, but still a carbon emitter. Natural gas or nuclear has no carbon emissions for generating electricity. And that can help us bridge until our solar and our wind and our other technologies are ready and able to give us the amount of electricity generating capacity that we've been getting with our fossil fuel use. I liken it to the way we've shifted with lighting. So lighting for a long time was an incandescent light bulb, which had a little wire inside of it that would glow, and it would get so hot that it would glow, and that's how we made our light. But it's 10% efficient and 90% inefficient. We had a toy here in the United States called an easy bake oven, and the heat source was a light bulb, not a very efficient way of making light. So we've shifted over to more efficient ways of lighting, and we had these little compact fluorescent light bulbs, which looked like a little ice cream cone with a tube that went up and twirled around and went back down into the base. And that was a more efficient way of lighting, but almost nobody here is using a compact fluorescent bulb anymore. Now we all have pretty much shifted over to LED lighting, because LED, light emitting diode, is much more efficient even than that compact fluorescent light. So I think nuclear power is going to play the role of a compact fluorescent light bulb, where we're going to use that to get us off of fossil fuel, but then we'll shift away from it as better things become available. Next question, how do schools in the United States teach climate change? That's a tricky question. In what grade does related education start? In what subject? When do you think students or the general public show interest in the issue? The best way to track attention? Okay. There's a lot of questions built in there, so I'll start with the beginning. Schools in the United States teach climate change in a variety of ways because our individual states have individual standards for their education. We don't have a unifying national standard system like other countries do. What Texas and New York and California and Indiana and Illinois do is going to be different from state to state. And so the focus is going to be different. So if you think about a state like Texas, which is very heavily oil company based, the focus for climate change is going to be less. If we think about a state like New York, which is a little more liberal, a little more progressive, the focus on climate change is going to be different, or Massachusetts. In general, your science teachers want to teach the science. So they're going to talk about how carbon dioxide is increasing. They're going to talk about the environmental impacts of climate change, what's happening with it. Your social science teachers might start to talk about the society implications of fossil fuel use, and current events classes might talk about it. But for the most part, here in the US, our education leaders are talking about what is climate change, what causes climate change, and what are the effects of climate change, environmental impacts that way. Students, our kids are such activists. They are great. They really want to be involved. And I think we as adults need to get out of their way. I really do. Especially our high school students, our college students. They have a lot of great ideas. They're really into social justice and making sure people are treated with equity and equality. The best way to attract attention of kids, we don't have to do a whole lot. Our kids have that here in the United States. Our kids have that mentality. My daughters are 23 and 27, and they have this mentality. My older daughter is an architect and very much into energy efficiency in buildings, and that was one of the focuses of her master's thesis, was energy efficiency in this building project. She and I talk about it all the time because I'm a certified energy manager and the things that I do with my job. My younger daughter is training to be a civil engineer, and she's really interested in water resources and water runoff and protecting the environment that way. I think we just need to encourage kids with their almost innate activism and not limit them and not stand in their way of the things that they want to do. All right, next question. Many schools in Korea are focusing on small changes like reducing plastic or using an LED. However, they tend to bury their heads in sand and come to bigger or more tangible changes like installing PV or reducing parking lot spaces. Also, because of the silo effect amongst departments within universities, they fail to cooperate with one another. Yeah, the egos can get in the way, right? How can student communities and local communities convince universities to actively respond to climate crisis? Can you introduce some best practice cases if you know? I don't know any specific best practice cases, okay? But let me back up a little bit. Those small changes, please do not put aside those small changes, because think about adding pennies to a scale, right? You just add little coins, little pennies over and over. You're going to start tipping that scale. So the little changes that we make, first of all, it's so much easier for people to make several small changes one at a time than it is to make huge changes. And so when you're meeting resistance, if people don't want to change 10 things, you're meeting that resistance. How about you change this and get used to that change, and then we'll change this next thing, okay? And that's what I promote within my community. I don't live in a very environmentally conscious or very environmentally active community. I live in a community of people who say, we've got the energy, I can use the energy, I can be comfortable. So I have friends who set their thermostat at 65 degrees Fahrenheit, which translates to about 17 degrees Celsius, right? And I'm like, that's very, very cold. Like, why do you, in the wintertime, that's great. In the summertime, your air conditioner is running all the time. So I'm trying to encourage them to just nudge that thermostat up a few degrees. Can you live with it just a little bit warmer and make a little bit of a change? So those little changes are important. Now, when you get to your university leaders, Show them the data. The International Panel on Climate Change, which is the UN branch devoted to climate science, they publish a report. I think the latest one is just released. They publish reports with the data. They have graphs and they have charts and they have data tables and they have discussions and they have all their references and scientific papers laid out. So those of you who are environmental science majors or science majors have the academic training to be able to interpret all that data and understand it and explain it in a concise, plain way, need to go to those leaders and say, this is the data. This is what climate science says. This is what's happening. Show them the glacier pictures. Show them the data about sea ice. Show them the data about what's happening to coral reefs. Coral reefs are dying because the oceans are getting acidified and the oceans are warmer. And we have bleached coral reefs. Show them all of those things and say, now, it is our responsibility to do things. Here are some things we can do. Which will you choose to do with us? Kind of put them on the spot, right? Not in a disrespectful, aggressive way, but say, this is really important to us as a student body, and we really need your leadership to take charge with us. And put them on the spot, not in a demanding, disrespectful way. You have to convince them. We have a saying here in the US, you attract more flies with honey than with vinegar. I really don't know why anybody wants to attract flies. So we'll just put that out of the way. But the point is well made, right? You're going to win more people over with sweetness than you are with sour. So that's really important, that you not get confrontational or put them on the defense. So reducing your parking lot spaces, what if you were to propose covered parking that has photovoltaics, PV, on the cover? So you have parking spaces, right? It's open, there's no trees. We have giant parking lots here. I don't know if you've seen that. We have massive parking lots here. It makes me a little crazy. But if we could have companies put in covered parking, which keeps the cars cooler in the summertime and keeps the snow off of them in the wintertime, and then just put solar panels on top of that cover, it's an expensive thing to install, but then that solar energy will then provide electricity for that facility and offset the cost of construction. That's a win-win for everybody. You know, a bus garage where all the school buses are parked, they could do that. There's just lots of things there. When you have university departments that don't want to cooperate, you have to get them in a community mind. They're competing for university funds. So the reason they don't really want to get involved in programs is they're afraid that it's going to take funding away from stuff that they think is important, or they're afraid that their piece of pie might shrink. You know, if I have this much money and I don't spend all of it, next year my budget might be less, and so I'm going to spend it, right? Well, you have to show them that it's not about keeping your piece of the pie, it's about reducing the size of the pie. That's what you really need to do. I'm going to click stop share, so it's not just a black screen. And thank you very much for everything. I don't know if our hosts have anything else they want to add. We've answered some great questions, had a great discussion. I really enjoyed this presentation and talking to you about it. Really enjoyed the preparation for it. If you have any questions at all, or you need to get in touch with us, our website is www.NEED.org. And that is a good way to get in touch with us and to find some information of things that we're doing here in the United States. And then if you want to send me an email, it's C as in cat, T as in Tom, URREL. So my first initial, my last name, C Turrel @NEED.org is my email. Thank you so much for attending. Thank you so much for being here. Good luck with everything you do. I look forward to continuing to work with the people at KEIA, and have a great evening.